Okay, it's another video on the probability distribution. I remember my humble self, Ishola Adedeji Mike, and this is Success Enlightenment. All right, this will be the eighth question we'll be solving on probability distribution. We want to be certain that you understand this, like you want to be certain that you can always deal with this all the time. All right, so if you are yet to subscribe to my channel, all right, I know you enjoy this quality content, so just please subscribe to my channel. It's a way of actually encouraging me to do more video. That's what that is to me. If you watch any of my video, give it a thumbs up. It's a way of also encouraging me to do more. And feel free to comment how my video makes you feel. If it's helpful, if it's not helpful, and if you have any problem with the video, like there's something you don't understand, where anybody can make mistakes, right? Even I do, right? So something you want to engage me with, just feel free. That's why I always attach my cell phone number to every of my content. So feel free to contact me. All right. With that being said, let's get into it. The worked problem 8. Which particular question do you want to solve uh on this particular video? Now let's take a look at this question, right? This question say in an unbiased dice, an unbiased die. Will I say unbiased die? It just tell you that it's a random experiment, because in a random experiment, every element have equal chance. Okay, they have equal chance. All right, that's just what it means. The grammar, don't let it affect you. He said in an unbiased die with six faces, definitely the unbiased and die still your is what you know already. A die have six faces: one, two, three, four, five, and six. If it's thrown five times, that is the number of time thrown is what, five times. All right, find the probability that a now for the fact that you're talking about a die and it has six faces, right? That's told you that this is a discrete word probability distribution, right? It's a discrete probability distribution. Now, it's thrown five times, all right? They don't give us anything, like we don't have the mean, we don't have an average. So definitely, since you don't have an average, you are going to use what, binomial distribution. That's the best way to approach this. So in the binomial distribution, you need to find your n, your x, your probability of success, and your probability of what, failure. All right. In an unbiased die with six faces, so the probability of is thrown five times. Find the probability that a factor of six appears three times. Now we're talking about the probability of success here, right? You have to look at how many factor of six can you have. All right. So you have to identify factor of six first. How many of them can you have? That's when you use to find the what, the probability here, all right, of success and of failure. And the second question is perfect square at what are the perfect squares, all right? And the last one, they have to find the mean, variance, standard deviation, and range of the distribution. All right, if you don't get everything I'm saying, I'm sure you by now everybody is confidently can find the mean. The mean is same thing as expected value, the variance, the standard deviation, and range of a distribution. I'm very certain that everyone can actually deal with that at the moment. All right, without too much wait, let's get into solving the question. All right, I think my humble self again, Ishola Adedeji Mike. If you had not subscribed to this channel, it's time to do. Subscribe to the channel. All right, let's go there. All right, we have an unbiased die. It has six face. All right, we've already explained that. So now, what are the factors of cis? That's the first thing we need to find in this question. What are the factors of cis? Are the first things we need to find. All right. Uh, Factors of cis. There are a number that can divide cis. We have one. One is a factor of cis. Two is a factor of cis. Three is a factor of cis, and cis itself is a factor of cis. Right? One divided by six divided by one is six. Two divided by six is three. Three divided by six is two, and six divided by six is six. So, all right. In a toss of a coin, sorry, a die. So we have how many factors of six? We have four. So, and how many do we have in a particular die? We have one to six. So which means probability of any of these factor occurring will be what? Will be four over six. Okay. Probability of any of these occurring will be four over six. And probability that none of these factor of six will occur will then be what? Will be two all over 6. Right? So here our P is what? 4 over 6. While our Q is what? Is 2 over 6. Now that we have find our probability, you find our probability. So now what is our n? Okay, what our n, the number of times here that this is toast is what? Is 5. And we have to find the factor of 6 appear exactly what? 3 times. So our x is what? Is 3 times. So we've already formed every part, every component of this binomial distribution. So all we have is to what? Is to solve for it. The factor of 6 appear exactly 3 times. That is p. What you are looking for is what? Is p, probability of when s is equals to what? 3. And that will be what? 5 combination 3. Probability of success, which is 4 over 6. All right, let's put 4 over 6 in the decimal places so it gets more easier for us. Let's press our calculator. What will be 4 over 6 in decimal places? 4 divided by 6, that will be 0.67 approximately, raised power 3. What is 2 over 6? Again, press your calculator. What is 2 over 6? That is 0.33, approximately 0.33. That raised to power, we have 5 minus 3, which is equals to 2. Okay, so now we have to find what is 5 combination 3. That's the first thing we are going to be looking for here. So from here, 5 combination 3, that is 5 combination 3. This will be what? 5 factorial all over 5 minus 3 factorial 3 factorial. And this will be what? 5 times 4 times 3 factorial all over 2 factorial. 5 minus 3 is 2. Then times what? 3 factorial. 3 factorial count 3 factorial. We are left with what? 20 divided by what? 2. Sorry, we are left with 20, not 2. We are left with 20. I left with 20. 5 times 4 is 20. 2 factorial is 2 divided by 2, which is equals to what? 10. So 5 combination 3 is equals to 10. Now that I know 5 combination 3, we have to press our calculator. What is 0.67 raised to power of 3? That is, we're talking about the probability of success raised to power 3. Okay, 0.67 raised to power of 3. So what will that give us? Let's press our calculator. 0.67 raised to power of 3. That will be 0.3 is 0.301. Okay, what about 0. Our probability of failure? Our probability of failure is 0.33 raised to power of 2. 0.33 raised to power of 2. What does that give us? 0.33 square. That's 0.109. 0.109. Now that we have find 0.67 raised to power 3 and 0.33 raised to power 2, so now we can go directly and find our what? Probability of x equals to 3. Right, you can find probability of x equals to this is what? P s equals to 3 equals to what? P of what? 3 equals to 10 times 0.109 times 0.301. Okay, that is what you get for our permutation. What we get for our uh, probability of success raised to power 3, and what we get for probability of failure raised to power 2. So now if we press a calculator, we have 10 times 0.109 times 0.301. 10 times 0.109 times 0.301. So our answer will be is 0.329. So therefore 328 rather, 328 8. So therefore our probability of exactly 3 times is what? It be 32.8%, or 32.8%, or put simply 0.328. And by this, this question is already solved. All right, let's check the other part to this question. Let's check the other part to this question. The other part of the question is the probability that the perfect square appear at most 4 times. All right, that's the other part of the question. And all right, what we have to do first is find the perfect squares. All right, don't forget we are dealing with the situation of a die. So in the die we have 1, 2, 3, 4, 5, then 6. All right, the perfect square in the die are 1 and 4. So we have only two perfect square, which means our what? Our probability of success will be 2 over 6, same thing as 1 over 3. While our probability of failure will be what? 4 over 6, the same thing as 2 over 3. All right, same thing as 2 over 3. Now that we find our probability in the question, already given our n to be what? To be 5, and our x that we have to find, it appears 4 times, is what? Is 4. All right, so now from here we proceed by applying our binomial what? Distribution formula. Proceed by applying our binomial distribution formula, which is p x, okay, equals to 4. That will be what? 5 combination 4. Probability of success is what? 1 over 3 raised to power 4. Probability of failure is what? 2 over 3 raised to power, that will be 5 minus 4. That's equals to 1. Okay, that's equals to 1. So from here 5 over 5 combination 4, 5 combination 4, that's going to be 5 factorial all over 5 minus 4 factorial 4 factorial, and that's going to be 5 factorial all over 1 factorial 4 factorial, and that's 5 times 4 factorial. 1 factorial is 1 times 4 factorial. 4 factorial cancels 4 factorial, so that's is equal to 5. All right, so what is 1 over 4? 1 over 3 raised to power 4. Let's just put that in decimal places. Okay, let's put that in decimal place to just ease our solving. 1 over 3 is the same thing as what? Is 0 point, that's 0.33, repeating, so raised to power 4. So what is 0.33 raised to power 4? This is our calculator. 0.33 raised to power of 4. What do we have? That will be equals to what? Is 0 point, that will be 0.0, okay, sorry, that will be 0.012, right? Approximately 0.012. All right, the other one is what? Probability of failure there is 0.33 raised to power of 1, and that will be what? 0.33. 0.33. Okay, 0.33. Okay, so now from here, now what we do from here is we put in our formula and we just multiply all through. Okay, so probability of perfect square appearing 4 times is, then the permutation, which is 5 times 0.012 times 0.33, right? So now what do we get when we multiply all this together using our calculator? Using our calculator, we are going to get 5 times 0.012 times 0.33. So what we are going to get is 0 point 0.0, sorry, I don't write the point very well. All you have is 0.0.019. All right, 198. So you can approximate this to what is 0.02. So that what in percentage that will be what 2%. All right, that will be 2%. That's probability of perfect square appearing 4 times. Okay, that will be 2%, and that's the answer to that task. All right. There's still one more part of the question. Let's look at that as we run this video, as we bring this video to. So the last part of the question asks us to find in both scenario to find the mean of variance and standard deviation and the range of the distribution. All right. The when you look at the first case that we have, we talk about the factor of 6. In that case, the probability, let's say the first case scenario here, the probability of success there was 4/6, 4 divided by 6, and probability of probability of success was 4/6, and probability of failure then was 2/6. All right, so if you are finding our mean here in that first scenario, mean is what n times what p. All right, and we talk about the number of times there was what was the number of time the die was toast, then was what was 3 was 5 times. All right, unbiased that 6 faces it through 5 times, so that we have 5 into what probability of what of success, which is 4/6. So therefore we have 20 divided by 6. So when you press that on your calculator, what does it give you? 20 divided by 6. When you press 20 divided by 6 on your calculator, what does that give you? We have 20 divided by 6. So that will be 3.33. All right, this is our mean for the first calculation. That's our mean. All right, once you find the mean, you can quickly find your variance. All right, your variance also is the formula for variance in the binomial distribution. Variance is represented by sigma square, that is square of standard deviation, and the formula is what? NPQ, that is number of times times probability of success times probability of failure, and that will be what? 5 times 4/6 times 2/6. So we already know what is 5 times 4/6 times 2/6. So we're just going to multiply our mean 3.33 times what? 2/6. All right. And if you do that, what you are going to have in your calculator, it be what? It be 33 times that's times 2 divided by 6, and that will be what? 1.11. So that's our variance. All right, that will be our variance. Now that we have found our variance, so we can find our standard deviation. All right, standard deviation is the square root of the variance, is the square root of variance. All right, which is therefore equals to square root of 1.11. All right, square root of 1.11. So just press your calculator. Press your calculator. What is the square root of 1.11? Right? Square root of 1.11 from my calculator is what? 1.053. Okay? 1.05. Sorry. Approximately that's 1.054. That's 1.054. 1.054. All right. Now that we have all this, now we have to find the range. Okay. Now the range here, which is R, will be what? Maximum value of the distribution minus the what? Minimum value of the distribution. While the maximum value of the distribution equals to the mean, okay, plus 2 sigma, that is 2 standard deviation. The mean here was 3.33 plus sorry, mean, yeah, 3.33 plus 2 into what? What's our sigma? Our sigma is 1.054. Okay, so yeah, this will be what? 3
0.33 plus what is 2 times 1.054? what what is 2 times 1.054? That will be 2.108. All right, 2.108. So this plus 3.33. So our maximum value will be what? 5 point what? 44 approximately. So that's our maximum value to two decimal places. Now let's find our minimum or value. Let's find our minimum value. Okay. Our minimum value will be the mean minus 2 sigma. All right. Now our mean is 3.33 minus 2 into 1.08. All right. Sorry, minus 2 into our sigma is 1 point. Our sigma is 1.054. Okay. So it will be 3.33 minus 2.108. All right. So now when we subtract 2.108 from 3.33, what do we get using our calculator? All right. So what we get from that is 1.22. That's 1.22 to two decimal places. So now we can now find our range. All right. Now we can find our range. Our range of will then be what? 5.44. 5.44 minus 1.22. Okay. And this will give us 1 point of 5.44. 5.44 minus 1.22. This will give us what? 4.22. And this will be the range of this distribution. Right, that's for the first scenario. That's for the first scenario. Now let's check for the second scenario. Let's check for the second scenario. Okay. Now second scenario, we're talking about the perfect square. All right. And there the probability of success. Probability of success for there was what? Was 1 over 3. And probability of failure then is what? 2 over 3. So the number of times there is still what? Is still 5. Okay. It does it those 5 times. All right. It's still the same thing 5 times. All right. So now we can find our mean. Our mean is still NP, which is what? 5 times 1 over 3, uh which is literally 5 divided by 3, right? And that is 1.67. Okay, that's our mean. So since we have found our mean, now we can find our variance. Our variance is sigma square, and that will be what? NPQ. And that will be what? 5 times 1 over 3 times 2 over 3. Okay. All right. And that's going to be the pressure calculator. That will be what? 1.11. Right. That will be 1.11. All right. That will be 1.1. Same thing as say 5 divided 10 divided by same thing as 10 divided by 9. So it is 1.11. Okay. Now that you have found your mean and your variance, so you can find your what? Standard deviation. All right, which is sigma itself. Standard deviation, which is sigma, is equal to what? The square root of what? Variance. And that's what? Square root of 1.11. And square root of 1.11, square root of 1.11. All right, square root of 1.11 will be what? 1.054. Okay, 1.054. Now we can find our range. Okay, can find our range. Our range will be what? Maximum value of the distribution minus what? Minimum value of the distribution. Why? the maximum value of the distribution is equals to our mean, the calculated, plus 2 times standard deviation, which is what, our sigma. All right. Now our mean that we calculated, the mean we calculated is 1.67. All right. We have 1.67 plus 2 into 1 point, what was our standard deviation? 1.054, 1.05 and 4. So this will 1.67 plus 2.108. All right. 2.1, 2 times 1.054, what does that give us? You can always cross check almost all the time using our calculator. 2 times 1.054, that's 2.108. So we are right. We are going to add this to what? 1.67. Okay, 1.67. So when you add that, what you have is what? Is 3.7 8. This is the maximum value of the distribution. All right, now the next thing we have to look for is what? The minimum value of the what? Of the distribution, and that is what? Our mean calculated minus what? 2 sigma. So the mean we calculated is 1.67, and our sigma is 1.054. So we have 1.67 minus 2.108. All right. So 1.67 minus 2.108, when you subtract 1.67 minus 2.108, so what you have is negative 0.438. That's what you have. That's our minimum value. Now from here, now we have to find our range. Okay, we have to find which is maximum value, our range, which is what? The maximum value minus the minimum value. So the maximum value we calculated here is 3.78. We have 3.78 minus our minimum value is minus 0.438, 0.438. So this is 3.78 plus, minus times minus is plus, 0.438. Okay, so when you add these two together, what you have will be your range. Okay, what you have will be your range. 3 point 3.7 3.78. That will be what? 4. The range will then be 4.218. This will be the range of this distribution. And with this, we come to the end of this exercise. We come to the end of this question. All right. I hope this is well understood. If your first time coming to my channel, I'm Isholaide Michael by name, and here is Success Enlightenment. Please, I will really much appreciate you subscribing to my YouTube channel. All right, so that when next I make quality content like this, you'll be the first person to get notified. With this, we come to the end of the video. Thank you.